So one of the questions has been about PTP monitoring, and we've discussed there are tools, and there is probably no silver bullet analysis tool out there. We're very fortunate at Leader that we have both the Leader Zen series and also the Fabrics QX series, and they provide very different views on what's going on with PTP. I mean, lots of people say to me, well, your test and measurement, don't you measure the same thing? But if you actually look at the Fabrics and the QX series, it is a fantastic tool for showing you what is happening now. And the graphical displays with the PIT histogram for your packet arrival and all of the timing charts are great for now. The Leader Zen series can show you those, and you've seen some earlier on where we've shown displays that anybody who's familiar with SDI and doing that against Black and Burst will know about. But the other great thing is that we can also display graphs that show you what's happened anywhere between 2 minutes and up to 72 hours. Because one of the things I've seen with IP networks is they don't tend to suddenly drop off a cliff, but they'll give you plenty of warning that they're going, something is about to happen and you're going to have a quality of service issue. And I think you see the same in your tools, don't you, as well?
Yeah, I mean, this stuff is all digital, and this stuff, it has a very bathtub curve failure type behavior very often. And we've got resilience, redundancy, we've got lots and lots of stuff to make sure the show still goes on. But the bottom line is, unless you're monitoring all of that stuff, you could be one failure away from disaster, right? I mean, we've got -7, but the red network will only pick stuff up as long as the red network's working. If you happen to have a failed blue network and then you fail the red network somewhere, you don't have any network. So I'm the many benefits that IP has brought are huge. And I think you could never achieve a lot of, you said it earlier on, you could never achieve a lot of what we're doing now with SDI, but with it is a level of complexity that requires monitoring to be treated as a first-class citizen rather than as an add-on later on. So I'm a big fan of people building decent monitoring in up front. And as you say, a lot of this stuff is about long-term trend visibility. And so you're right. I mean, our cloud vision has got, I believe we store data for roughly 3 months. So, one of the things that does allow you to do is to go back and have a look. If there's a problem 2 months ago, you can see whether that problem looks the same as a problem you just had yesterday. And that kind of visibility is, it turns out to be absolutely invaluable at the point when you need it. And the problem is you've got to convince yourself you need it before you need it.
Yeah. I'm just going to pop up a slide because obviously we sort of talked about PTP. There's a couple of things that I'd like to show people, and this graphic we've put together. As I said, we're not going to go into all the messages bouncing backwards and forwards, but looking at T2 minus T1 and T4 minus T3, those will give you a very good indication of what could be going on. And I use this analogy here, that if you decide on Monday morning that you're going to go and work in the office and you need to be there for 9 o'clock, you will probably be joined by everybody else who's had the same idea. However, if you've left the office at 9 o'clock and are driving home, you're going to get there a lot quicker. And that's what T2 minus T1 and T4 minus T3 is showing you. So it's always worth, as I said, understanding what the timing is on your system when it's working. And we alluded to it earlier on that basically we had a problem when we built our system at NAB. You guys kindly loaned us a switch when our one went missing, but it was a transparent switch, and we designed our network around a boundary clock. We plugged it in 2 o'clock on a Saturday afternoon, it was working fine. 8 o'clock in the evening, some people were starting to flash and bang. We were starting to lose. And suddenly, by looking at these timings here, we could see that our poor old grandmaster was being very polite and responding to every message that every device on the stand was sending him. And, you only learn about this stuff when you see it firsthand, don't you?
I think you're right. I think we are, we are creatures that understand and analyze patterns. And so I think, and we get used to a certain thing that looks right. I mean, this is all sounding a bit AI and machine learning-y, isn't it? Really? I mean, that's
Yeah.
exactly what we are. I mean, in a boundary clocked environment, if you saw those numbers, you would, not the scale of the numbers, but the asymmetry of those two numbers, you'd be worrying a little bit, because in a boundary clock system where you're connected point to point to something else, those numbers should be identical because the bit of fiber is the same length. So that is saying there's, those numbers are saying there's some sort of asymmetry in the length of the fibers, or in the path, or it's saying there's some sort of difference in how well, you said it's a transparent clock, so that makes perfect sense, right? There's a longer distance through one path of the network than there is on the return path, and that would result in you having PTP that's locked pretty well, but with an offset, because the assumption is that it's, essentially those numbers added together divided by 2 is the network latency, which is not right in either case now.